So we got two sites between which we want to do a secured tunnel, a VPN, an IPsec tunnel. But for the phase one, we would like to use a certificate, a public key signed by the certification authority instead of using a pre-shared key. That's the difference between the previous one and this lab. As we spoke earlier, only the phase one is going to be different. Phase two, it's the same configuration. Phase one is going to be different. I would like to. You mean different with previous one? Yes. Phase one configuration is going to be different from the previous lab that we did with pre-shared key. You remember we did a lab with the pre-shared key Cisco 123. This time we are not going to give any pre-shared key. A public key will be used with the CA signature to negotiate phase one tunnel between these two sites. The story about PKI, how they work, how the certification authority works is already explained in the previous class. Today our focus is to see the configuration part, and also using Wireshark we are going to capture some packet to see what all goes inside the packet. Initially, I am not going to start the Wireshark because we are not going to have IPsec in the beginning. We will need to have reachability between the sites and the CA server, for which a basic routing is what I'm going to focus. So there is no need for Wireshark. After which, when we start IPsec, we will turn on Wireshark, a packet capture, an analyzer, a sniffer. Now, that CA server that you see here, which looks like a computer, a server, which is not really a server, it's a Cisco router. We can make use of Cisco router to be a CA server in a small Soho environment, small office, home office environment. You no need to hire, you no need to subscribe for a CA server. You can very well use a Cisco router to sign your certificate. So I would like to start from the CA server and then I'll go to sites. When I start the actual site-to-site configuration, I'll start from CA server. But before that, we need to finish the basic IP address configuration. Let me start from the left-hand side. The left-hand side PCs IP address will be 10.1.0.1, mask is 16, or let's keep it as 24. And the gateway is 10.1.0.10. You see, I'm assigning this IP address on this PC. This is where the traffic will be initiated from this site. So we want all the traffic from this 10.1 going to this computer, which is going to be 10.2, to be totally encrypted. So here we go. I say IP 10.2.0.2, 10.2.0.10. So we got the IP address configured. Now let us move on to site 1 router. I would like to use a notepad so that I can do alteration and paste it on the other routers. This will reduce my time taken. 10.1.0.10 255 255 2550 interface G3/0 14.14.14.1. Now I'm going to put OSPF IP OSPF1 area 0. Please listen, I'm not putting OSPF on the LAN side, only on the WAN side I'm putting this OSPF. And then I say end write to memory. This is what goes on router 1, site 1. Now I'm going to do alteration on this configuration. So let me put it on under the heading called site-2. And this IP address will change here. It is going to be 24.24.24.2. And on F0, it's going to be 2 here. 10. Nothing more. Let's copy and paste it on router 2 site. Now the CS server IP address need to be configured. Nothing bigger. So don't expect anything much here. We are just going to put the IP address and the OSPF. See, nothing more other than that as of now. And okay, dot 2, and I'll paste this. That's all, nothing more, just one interface.
Just 1 moment. Which interface is it? Okay. But the IP address is 34.4. But you put there
No, see here on the server, dot 2 I have given. Okay, so this goes on the CS server. Next is the middle router, the internet router need to be configured. I'm going to use the same notepad, and this need to be 2 more times pasted because we got 2 more interfaces. Okay, let's come from the beginning on the top. 3/0 will have 14, 14, 14, 4. And then 4/0 will have 24, 24. And then 5/0 will have 34, 34, 34, 4. Okay, I'm expecting 3 OSPF neighborship. Okay, router 1 has already joined. Server CA7 has joined, and
Site.
there is a mistake. There's a mistake. I have put the same IP address on both the routers. There's a mistake. I need to go to site 2. There is a mistake in the IP address. Show IP interface brief. Uh-huh. No, it sounds good. There's no mistake. Show IP OSPF neighbor. How come two neighbor having same IP address? So on this 4/0 and on, oh, that's the router ID. That's okay. But it is not okay. We need to clear the OSPF, clear IP OSPF process. See, it has already found duplicate router ID detected. Oh, so funny. Show IP interface brief. Protocol. Okay, the router ID problem is fixed. Now let us go to internet and check show IP OSPF neighbor. Okay, clear IP, show IP OSPF neighbor. Okay. We got the neighbors. Show IP protocol. I would like to see the router ID. This is 14, 14, 14, 4. It's okay. Now, all that I need is reachability between site 1 to site 2 to site CA. Let me try pinging 14, 14, 14, 1, which is site 1. I'm able to ping 34, 34, 34, 2, which is CS server. I'm able to ping. See, VPN is not the routing, so we need routing. VPN is to protect our data, that's all. So data between the PC1 and PC2 need to be protected. That's our aim. Right now, if I ping from these computers, I will not be able to ping unless the VPN comes up. 10.2.0.2, I'll not be able to ping. See, it says destination host unreachable because the site 1 don't have a tunnel to go there to site 2. So we need a tunnel to go there. Now, the main story begins now. I'm going to sniff packet coming to this interface on site 1. Start capturing, and you will be seeing a lot of traffics, OSPF and so on, but we want to exclude OSPF. So I would like to put a filter saying I don't want any OSPF packets. Apply as filter not selected. So see, OSPF is removed. You understand? There is no OSPF packet. And I also don't want to see CDP packets. What? And not OSPF. I said I don't want to see CDP, I don't want to see OSPF. It is removed. But what is these packets? These packets are simply, kind of keep alive going. Let me also say copy the filter and say and not. Okay, so all those packets which was simply coming, I have removed. I'll add this as a filter list. Basic L2 basic. Boom. You see, if I remove this, you will get all of this. But I don't want all these things. These things are not IPsec. Have we started IPsec? No. We have not started IPsec. You understand what I'm doing? I don't want to see all these things when I have IPsec. This will sometimes distract us from learning IPsec. You agree with me?
Yeah, you said no layer 2.
Yeah. All right. So yeah, I removed all this OSPF and layer 2 packets which was going. Now let us go to CA server first and start configuring the CA server. First thing is you need to make sure the time is same on all the device. The time, show clock. Check it. It should be same on all the sites and the CA server. What is the time there? 28:22 Wednesday. 4:41, 4:39. It is okay. 1 minute different is okay. What about site 2? Show clock. 4:40, 4:40 here also. 4:41. 4:41. 4:40. 4:40. This is still 4:40. This is a little bit slow. CSM. This is very slow. So let's change the time. Clock set. Done. So I'm expecting now the same clock. Show clock 42, 42, 42, all are 42. Seconds is okay. Now we got the clock synced. You can also use the NTP to synchronize the clock. Now next is we need to generate an RSA key. This will be used to sign the certificate, for which I go to the CA server and I say crypto key generate RSA module, means the size of the bits. I want it to be 1024, means 1 gig. I want to give a name to identify this key, which is going to be generated as certification authority signature. This will be used to sign. So I named it like this. So let me paste this for you in a notepad so that you will be using it for reference. On CA. This is the first command I did. Before that, make sure the clock is For that, okay, let me just copy that one sample command. This is the sample command. You need to do similar configuration on all the device. Same time to be seen in all devices. Fine. Next is, after we generate the key, we need to enable the web server. Why? I told you the certificates will be downloaded using HTTP or HTTPS. All communication are done through HTTP or HTTPS. So I go under configuration mode and I say IP HTTP server. That's it. Next, we need to configure this as a public key infrastructure server. This as a CA server. For that, wait. Before that, let me put this one. Okay. This is to enable HTTP server. Now next is to enable this router as a CA server. The command is crypto PKI server, and then call this key that you generated. Right? Fine. What is next is we need to tell who you are. So you are a certification authority. What is your name? There should be a name for the issuer, certificate issuer, whoever issues the certificate. That organization should have a name, no? So I say issuer name, the common name, let's say Joy. Next is the organization. Organization is Joy Networks. And then organizational unit. What is this organization doing? It's educating. Education. And where it is located? Bangalore. In which country it is located? India. Boom. See, this issuer's name, organization, all this will be appearing in the certificate on site 1 and site 2 when they download. I'll show you there. We are configuring this on CA server, but you will be seeing these things on site 1 and site 2 certificates. Site 1 and site 2 public key. Next is how the certificate need to be issued. If someone comes for certificate of public key to be signed, how it needs to be certified? It needs to be granted automatically. There is also another way where you need to manually interfere and say grant. See, there is an option where we can manually go and authorize when a request comes. Auto is best. At last, you need to say no shutdown. No shut. And it is asking a password. What password you want to give? See, some server settings cannot be changed after. Please enter the phrase to protect the private key. How do you want to lock it? If you want to do changes, you can put the same password and come and do changes. So what is the password that you want to give? I would like to give Cisco 123. Again, Cisco 123. See, we have generated a signature. We have generated a crypto key to do signature. If you want to do some changes to the signature, like you want to change the organization name, something like that, you can come and put this password and do the changes. Okay, so on the certification authority, means CA server, all the configuration that need to be done is over. See how simple it is. The CA server is ready. Let me paste. This is the signature that we generated, and this is what the configurations that we made. There are a lot of things which has automatically come. All right, so we only configured this part. We configured only this part. And also we gave the password phrase. So better I'll just paste it in a notepad and do what I did in the command line manually. So after this, what it was, when I was saying no shutdown, it was asking me the password. So let me write here. And I gave Cisco 123. I'm setting the password. It was asking me to retype the password. So again, I gave Cisco 123. That's all. This is what I have done on the CSR. Now, if you see the public key which will be used for certification as signature, this is the command show crypto my pub key crypto RSA show crypto key my pub key RSA. See, this is the signature server's key, which is not an exportable, that will be used for signing. Okay, so next is we need to do the configuration on the client side, site run. Now on the client side, what need to be done? On the client side, we have to first of all generate the public key and the private key, and then using the public key, the site router needs to go to CA server and enroll and get signature from the CA server and download that signed certificate from the CA server. This is what a client needs to do. The site 1, site 2 router, before they form VPN, they need a signed certificate, for which they need to go to the CA server with their public key. So first is they need to have a public key. Let us generate a public key. Crypto. No, before that you need a domain name here. This needs a domain name, IP domain name. Let me say co.com. That's a domain name. So very first step, give a domain name. On the on the site routers. All right, this is the first thing that you do. Next, we have to generate a key, crypto key, generate RSA key, module 1024. This is the size of the key. Now you will see a key is generated with a name called site-1.co.com. You can also see the generated key here, show run. You see, you will be seeing the key show crypto here. You see a key with the name site1.co.com. This is the public key. All right, now this key need to be sent to the CA server. For that, I need to know where the CA server is. Crypto, public key infrastructure, trust point. I can give any name for the trust point. I'll say CA-server. And then I say enroll using the URL HTTP. You remember we enable HTTP server on the CA server. The reason is we use all communication through HTTP. What's the IP address of the CA server? You're not focusing on class.
Yes.
Yeah.
I focus. I see.
So we are letting know where the server is located. Now, at any point of time, you can cancel the signature that you got signed if, in case you don't want to do VPN. You can revoke the certificate. Means you can cancel the certificate. But here we don't want to do that. I say revocation, check none. Next is, see, this is very important section. Wait, let me paste this thing first. For your reference, I need to put this in the notepad. We generated a key. No, where is the key that we generated? We generated key here. We generated the key after this. We generated the key and then we gave the trust point enroll command. Enroll. And then we have said the revocation check is none. And then what is next is I need to download the CA server certificate. So now I need to send my certificate and download the signed certificate. What else we did? Okay, this is the final part. Very important part to download the certificate. Crypto, not here. Crypto, PKI, authenticate. What is the name we gave on the top? Trust point, CSO, this one. Authenticate this, meaning, first of all, we need to authenticate the server from where we are getting certificate. So we cannot get certificate from someone in the internet. So for that, we put this command, and it is asking you, are you sure you want to accept the certificate from this IP address? We are giving permission, yes. So this is the fingerprint. We are saying yes. Yes. And next is, we need to enroll our public key to get the certificate issues. See here, the trust point is accepted. We have accepted the trust point, means our CS server as the genuine one. Now we are saying this is my public key. Please sign it for me. How do we do that? Crypto PKI enroll and enroll with this server. It is asking the password. So create a challenge password. Let us keep the same password that we gave in CS server. Cisco 123. Cisco 123. And it is asking like include the router serial number. Your wish. If you want to include the router serial number in the key, you can say yes. Do you want to include the IP address? It's your wish. If your IP address keeps changing, then say no. If your IP address is same, then you can say yes. I would like to say no. Request for a certificate? Yes. Now your certificate is downloaded. You want to see the certificate? This is the command. Now you see the certificate will have the date, time, you see, the serial number. See, this where we configure these things. We configured on the server. CS server has put its signature here. All right, it has put the signature and signed our public key. Our public key is signed by the CS server. This is the period, like 3 years. 3 years it has signed it, the validity.
Okay, so it means you have communication side one CS is because of that reachability of voicemail, something like that.
Yeah. That's right. Now, this is exactly the same command configurations that we need to put it on the other side, side 2. So I'm just going to copy this and paste it on side 2 router. Next is on site to router, we are going to download the certificate. For that, crypto PKI authenticate the name of the server which we gave. Okay, let me paste this for you in the notepad also, which is missing in the notepad. This is to download CA server root certificate. When you give this, it will ask you, are you sure you want to trust this guy? You need to say yes.
Okay.
All right, so let me see. See, it's asking, do you really trust this guy? Do you want to accept certificate from him? I say yes. See, trust point is accepted. Next, we need to now go and enroll with the certificate issuer. So next step is enroll our public key with CA server. What is the command? Crypto PKI enroll ABC. Not ABC. CA-server. And then it will ask to set the password. You set the password. Cisco 123. And then you need to follow the screen. So what is next is, we have said this, no? Next is enrollment. Crypto PKI enroll with this certificate server. It's asking me to set the password. Hey, come on. The password is Cisco123. Cisco123. Oh, do it again. Cisco123. Cisco123. Done. Do you want to include the serial number? Yes. Do you want to include the IP address? No. Do you want to request for a certificate? Yes. Done. So here also you can go and check the signed signature, signed certificate. So this is for site 2 with a serial number so and so is being signatured for code.com and the date is 3 years validity. It was signed by the organization called Joy Networks from India, Bangalore. Next. That's all. You need to now use this in site-to-site VPN. So whatever so far we received from the CA server is listed here. All these things you received from the CA server. You see, who is this 14.14.1? It's my site 1. Site 1 is sending a HTTP request. See, port number 80. TCP 80. It is sending a request. And the flag is a SYN packet. It's a SYN packet. It's the very first packet. It's not real data packet. It's a SYN packet. The real data goes here. You see HTTP. The real data goes here. Hypertext protocol, HTTP. I said this will be used for downloading the signed certificate. You see, fill request. This is the HTTP request. Whose IP address is this? Is the CA server's IP address. Yeah. So it is sending a HTTP request for the certificate. See, get CA certificate and message. You understand what I'm saying? Do you follow?
Yes, but on the router site 1, there we begin to try to have a communication with site 2.
No. This is not site 1, site 2 communication. So far, we have not started any site 1, site 2 communication. I'm showing you how the certificate, signed certificate, is downloaded. See, before you form site-to-site VPN between these two, before you communicate between these two, before you form VPN, you need a signed certificate to show to the other site. You understand that?
Yes.
That is what happened so far. Now I'm showing you that site 1 has sent a request and it is sending a request like this. Give me the certificate. You see, operation equal to get CA certificate and message from the server. It is asking the server, give me the certificate. All right. Now you are getting some responses, but certificate will be downloaded in HTTP. So I will go to this HTTP packet. Look at this. Here is the response packet. And this is the certificate. But those things cannot be captured for security reason. It is not capturing. So the certificate request was made here. And you see the response is in the frame 843. I am right now in what? 838. 843 is here. This is where the certificate response has come. Even see, you can see the arrow mark. request went like this, the response has come like this. You see that?
Yes.
So certificate got downloaded here. And then again, client 2 was sending a request, which you will see here. This is client 2, site 2. Site 2 is sending a request.
Yes.
And it has received the certificate. HTTP. So response you will see 9:30, which is down here. This is 9:30. So we see that the certificates got downloaded. Now using this certificate, we need to do site-to-site VPN. Do you have that? Now on site 1, I'm going to do the IPsec configuration, crypto, ISAKMP, policy 10, authentication using PKI. Authentication using RSA. That's what PKI. RSA signature. And then encryption, let's say 3 days. And then hashing, let's say MD5. And then group 5. Okay. So this is what I have just configured for phase 1. Let me put it in the notepad for you. IPsec next. Phase 2, crypto, IPsec transform set, tset. For encryption, use AES. For hashing, you use MD5 HMAC. Next. After this, access list. Access list 101, permit IP from 10.1.0.0 to 10.2.0.0. Okay. So this is the access list. Access list is done. What is next after access list? The crypto map. Crypto map, CMap 1, IPsec, ISAK, AMP. Set peer. Who is the peer? 24, 24, 24, 2. Sorry, not 4, 2. 2. And then set transform set tset. And then match IP address, match address. What is the access list number? 101. Do show history. So these are the things that I have put. Finally, we need to apply this on the interface. Interface G3/0. Crypto map CMAP. So what will happen is it will take the certificate and go to the neighbor router, the peer. You will not see that now because we need to initiate the traffic. We have not initiated any traffic.
Yes.
Now, I have to do the same thing on the other side. Site 1 is over. Site 2.
Site 2, yes.
So for site 2,
My bad. My bad.
it's okay. In site 2, one small change in the access list and the peer. Now this will become 2 here, and this will become 1. And this will become 14, 14, 14, 1. That's all. I'm going to copy this and paste it on the remote site. Site 2. All right. Now, even if you go now, there won't be anything fresh packet so far. We need to generate the traffic. For that, I'll go to this PC and try pinging. No, the reason is we need to write one static route so that the traffic will try to go out via that WAN interface where CryptoMap is binded. So I'm saying IP route, if you want to go to any 10 network, other than what you know, any 10 network, you need to just send it to a G3/0. This will just go and initiate the crypto. I'll put the same thing on site 2 route. Now if you see, I have Wireshark ready and I got this PCs. Wow, look at this. Okay, it has learned the ARP, but I'm not able to ping.
Did you the static route from you choose the good interface to site from site 2 to site 1?
Wait a minute, what did you say?
The static route from site 2 to site 1.
It need not to be an accurate route. So this is what I wrote, but I'm going to do some alteration to it. Instead of this, I'll give. It is not a static route to that final router. We are just pointing towards the internet, that's all.
Yeah.
We need to point towards the internet. Now let me try to ping again. Yes, ISAKMP. ISAKMP is nothing but phase 1. And the ESPs are the one encrypted packets. So we are able to ping. Now let me go to ISAKMP. See, ISAKMP, Internet Security Key Management Protocol, it uses UDP 500. And it's a security association. And then the payload is IPsec. And I'm expecting a heavy payload here. Okay, the main mode starts here. Okay, the encrypted data is 7. This is what actually carrying the certificate. The encrypted data 754. You cannot see the certificate here. For security reason, Wireshark cannot show you all those things.
Yes.
Okay, but all the ISIM packets are going as ESP packets. Encrypted. Fine then, let's stop here. This is how the certificates can be used instead of pre-shared key. All right, we stop here.